Welcome you all. Continuation to the previous lecture video. Today we will study about different relationship among mass and volume relationship. Okay, different mass and volume relationship. So, as we have already seen, soil is a three-phase system. In a vertical way, I am just showing you. One phase is solid, another one is liquid. Okay, say these are the solid, then your liquid, then your gaseous substances. Soil is a three-phase substance. If we donate just with we can say this is the volume of soil solid. We can name them as volume of soil water, volume of air. This side we can write mass of air, mass of water, mass of your soil solid. And these are pore space, we can say mass of the pore space. For pore space I am denoting with F, small f. Okay, whatever with W, A, F, it is S for solid. You can say this is the volume of pore space. Okay, and if we see the total volume, we can see this is VT, total volume. Okay, also we can name them as MT, mass of the total soil. Okay, just remember these conventions. Now we will see the relationships. Coming to density, first one we can see soil density. We see soil density. What is density? Density is mass per volume. Very simple thing. If you see, one is your bulk density, and I will write side by side so that you can correlate and easily remember. Another one is your particle density. So what is particle density? From name itself you know this. Mainly we are talking about particles or minerals. Okay, particle means density, mass by volume. You can say mass by volume. Okay, we are talking about particle, so particle will be solids. Okay, here volume of soil solids. Very simple. So mass per volume. Mass we generally give the unit gram, or in volume we can say centimeter cube. Okay, this is CGS unit. If you give SI unit, we can say this is megagram per meter cube. Okay, this is the unit. And coming to bulk density, we are talking about the bulk soil. Okay, so here also mass per volume. We take normally it has mass of soil solid by total volume of soil. This is called as dry bulk density. Bulk density I can write it as rho B, bulk density. For particle density I can write as rho P, or in some books it is written as rho S. Okay, simple. This is, don't get confused. So now if we actually bulk density we can write mass of water plus mass of solid. Mass of air almost neglected. Mass of air is normally neglected, so we can write mass of water plus mass of solid by total volume of soil. But normally this is called as weight bulk density. Okay, normally you should have, you may ask that why sir we are for our practical purposes, why we have take this dry bulk density only, why not this weight bulk density? So you just think the moisture content changes from day to night, and also within few hours this changes, so it will be difficult for us to tell a bulk density value which is generally changing. Okay, so we normally take this as the bulk density. Okay, this is the main thing. Okay, I think you may get now the point. Also we can say we are taking the bulk material, we can say it is also apparent density. Okay, and here in particle density we can call it as, we are taking the real minerals, so we can call it as real density. At field condition normally we use core sampler, okay, for determining bulk density. We will detailedly discuss in our practical class. Here we normally use pycnometer method. Pycnometer method. So now we have discussed different textures, normally coarse texture and fine texture soil. So for coarse texture soil, we can say for coarse texture soil, the values normally ranges from 1.3 to 1.6 megagram per meter cube. I have already told the unit. Okay, and for fine texture soil, you can say the value mostly 1.1 to 1.3 megagram per meter cube. Okay, now here the value is normally depend on the type of minerals present. Normally in general condition we take 2.65 gram per centimeter cube or megagram per meter cube. Okay, these are the values. Also we have discussed about structure. Okay, if the soil structure, if there is blocky like of structure, okay, the presence of prismatic, blocky or this type of structure, the bulk density will be higher. Okay, and if there is presence of your spherical type of structure, this will be lower, your density will be lower. Mass will be decreased or presence of more organic matter. Okay, we can write presence of more organic matter. Okay, so organic matter mass is very less, so bulk density will be less. It may reach up to 0.5. The value may reach up to 0.5. Here if the organic matter present, the value may reach up to 1.1. Okay, this varies depending upon the kind of organic matter present. And another difference we can say that if, okay, yes, remember, doing cultivation practices, the bulk density, because the pore space effect is there, we are taking the total volume of the soil. So during cultivation, the bulk density value normally changes, but the particle density values normally do not change, because there will be presence of same kind of minerals. Just we are doing tillage or different cultivation activities, but the mineral content will be same. So that's why particle density value doesn't change much by cultivation. Another point, you can say, if the mineral composition is affected, so which type of density will be more affected? This is particle density. If the mineral composition is mainly affected, then particle density will be more affected. This type of questions generally come. If you compare, then it will be easier for you to remember a large information, a lot of information at a small point. Okay. Normally this particle density is not affected by pore space. This is not affected by pore space. Remember, this one is the important point. This particle density is not normally affected by pore space. Then coming to another density, which one we can say wet density. Now we can say we have discussed about soil density. In soil density, another 1 to 2 terms are there. We can say voidratio. Another parameter is there, which is called as voidratio. This is normally given by volume of pores by volume of soil solvents. Okay, this is normally used for engineering purpose. Normally used by engineers. Okay, and this the value may vary. The value may vary from 0.3 to 2. Just remember. Okay, and coming to another parameter, which is specific volume. This specific volume is simply, we can say, reverse of or inverse of bond density. Specific volume, okay, we can term it as inverse of bond density. Okay, we'll try to solve some problems so that the concept will be more clear. Okay, so specific volume value, that bond density was higher for your fine texture soil, your coarse texture soil. Here this will be just opposite. For your coarse texture soil, your value may be 0.332, 0.552, 0.70. If the unit is just opposite, meter cube or megagram. Simple. For fine texture, the value will be here 0.72, 0.70 to 0.90. Okay, unit is same. This much you remember. Then coming to your pore space. What is pore space then? What is pore space? This is very important. What is pore space? This is where we can write volume of pore space. I am writing this F. Okay, volume of pores by total volume of soil. Okay, this is very simple. But normally in pore space also we write in terms of bond density and particle density. We can write it as 1 minus bond density by particle density into 100. Okay, if we write in terms of bond density, this is derivation is also easy, but I am not deriving here, it will take more time. Okay, you can just simply follow your textbook also for derivation, but derivation is normally not asked. Just remember, when you practice more and more problems, this will happen to be remembered. Okay, very easy. And if we see some factors affecting pore space, these are also important. You can say first properties factor affecting is texture. We know if there is fine texture, the more number of micropores or total porosity will be there. So normally in case of texture, the fine texture soil will be having more pore space compared to your coarse texture soils. Your fine texture soil more than that of coarse texture. But there is tricky question many more times asked, that although if we change the total pore space, if we change the size of the particles, let's consider that cube is there. Okay, cube is having porosity of 47.47%. Okay, let's consider a cube is having its total porosity of 47%. Now we change the sizes from 1 millimeter to 0.01, 0.001. Like this way, we have this is coming in sand sizes, this is coming in silt sizes, this is coming in your clay sizes. We have changed the sizes of the particles, but the total porosity doesn't change. Okay, remember here, by changing the sizes, size changing doesn't affect your total porosity. It will affect your pore size distribution. Okay, these size changes will be affect your pore size distribution. But normally in case of cube, the size changes does not affect your total porosity. Just remember, and if you want to be make sure, also follow your first question from that Interrelationships. That it is explained. Okay. Then another property is your structure. I have already told the structure. The more the crumby, the structure will be good. So more porous will be your crumby compared to your granular. This will be followed by your block-like structure. This will be followed by your block-like structure. This will be followed by again by pigeon-like structure. This will be followed by your plate-like structure. So in terms of porosity, we can say the least porous soil structure is plate-like soil structure. Okay, the highest porosity will be crumby. Why this porosity is important? Because it will store the water and air that is needed for also plant growth. Okay. Then coming to the another property or factor affecting this soil porosity is your organic matter. We know if there will be more organic matter, the more porosity will be more. This is very simple. And presence of microorganisms. I am not writing here. I am just telling you. Note down. Then presence of microorganisms, there will be more porosity. Okay, this will be helpful. And if we increase the depth of the soil, another factor is depth of soil. If we increasing the depth, the porosity will decrease. Simple. If the compaction is increased, okay, compact means you are compacting a coherent mass and removing your water, air, all these things. Okay, porosity is reduced. Simple. And if puddling is there, all the pores will be filled with water, saturation is achieved, so there will be reduction of your what? Soil become denser. Then coming to different water properties. Now we have discussed the soil density or soil property. If we see water properties, or we can say soil wetness, we give these two units generally. One is called as mass wetness, or we can say gravimetric moisture content. Gravimetric moisture content, or we can say wetness. Okay, this is called as mass wetness. So mass wetness, we are talking about water. So it is simple, mass of water by mass of solid soil. Okay, that's what I call it. Okay, very simple. And normally at saturation, we can denote this as theta G. Okay, normally for mass wetness W. Okay, so at saturation, normally the value happens to be 25 to 60%. Remember. Then another important one is your volumetric moisture content. Okay, or we can say volumetric wetness. We can give this unit as theta V. This is theta V. You can write down as volume of water by total volume of soil into 1. Okay, this is very simple. We are talking about volumetric. So total volume will be taken, volume of water. We are talking about mass wetness. So mass of water by mass of soil solid. Okay. Now, if we see normally volumetric moisture content for sandy soil is 40 to 60%. For clay soil is normally 60%. As the clay content increases, the moisture containing capacity will be increased normally because the micropore content will be more. Okay, if we remember also, if we don't have the this value, but we have ball density value and mass wetness value. So normally what we do, we just multiply this gravimetric moisture content with your ball density. Okay, just multiply this gravimetric moisture content with ball density we have. Okay, then normally we get the volumetric moisture content. And if we see here, what is the degree of saturation? Degree of saturation is your volume of water by what? Volume of pore space. Because we are talking about saturation, so what will saturate the water? Where water will go? To pore space. So it is written as that volume of water upon volume of pore space. Okay, into 100. This saturation can go up to 100%. Okay. Now coming to the, we have done soil, then water, soil solid portion. We have seen some parameters. Now water portion. Now we will see air. Okay, soil air. Now we will give soil air in quantitative terms. If you want to calculate the air filled porosity, or you can say fraction of air content. You can say this as, okay, you can say fraction of air content. This is very simple. Volume of air by total volume of soil. Okay, we are talking about air now. So if you want to quantify this air, how much air is in your soil, you can calculate air filled porosity, which is given in terms of volume of air upon total volume of soil. Okay. Now, if you want to interrelate all this, okay, if you want to develop a interrelationship among these parameters, relationship or interrelationship, you can say among these parameters. We have already discussed one or two, like if in terms of porosity. Okay, what we are giving porosity? 1 minus ball density by particle density into 1. The derivation is easy, but you just work out yourself. Okay, if it is difficult, ask me, I will solve. Normally the derivations are not asked. Okay. Then another we have done that volumetric water content is your moisture, gravimetric moisture content into ball density. Another in terms of your porosity and void ratio. We have discussed porosity as well as void ratio. We can say this your porosity is given by E1 plus E. Okay, E is void ratio. I have already told you what is void ratio. Okay, so if coming to, if we have void ratio value, we can also calculate the porosity. How? This E equals to F minus F by 1 minus F. Okay, remember. Also we can say if your volumewetness theta, okay, if you just minus your volume of fraction of air content from your pore space, you will get volumetric water content. Okay, now we will try to solve a problem and understand this concept better way. This volume mass chapter is very much dependent on how much problems you practice. Just simple. You will practice, the parameters will be more easily remembered. I am written down a problem for you to solve in class. Just think, question are given. A soil sample collected with a cylindrical pore sample having height of given the height of pore sample What is the question? Given height of pore sampler is your 15 centimeter and diameter is given 6 centimeter. Your trace weight of soil given 675 gram. Okay, your oven dry weight given your 550 gram and your particle density is given. Normally I have told you what you take 2.65 megagram or gram per cc centimeter cube. So normally written as cc. Okay, this much has given or asked us to derive void density, your specific volume, your porosity, your void ratio, all this we have seen. We will calculate from this problem. Okay, so coming to first one, which one is your void density. You calculate yourself and check here. Okay, your void density is, we have seen, it is mass of soil solid by total volume of soil. What is the mass of soil solid here? 550. Mass of soil solid oven dry weight means this is the mass of soil solid. Okay, this is given 550 gram. But we don't have the total volume of soil. But how can we calculate the total volume of soil? We can say, from this soil pore we can calculate. Okay, normally the volume of soil pore or total soil we can calculate by this formula, pi r square h. Okay, just put the formula. Here it is given diameter, we can know the radius. This will be 3 centimeter. Just put here, this is 22 by 7 into r square, 3 into square 9. Okay, and height is given 15. After calculating this, we will get the value 423.9, okay, centimeter cube. Or for convention I am writing 424 centimeter cube. Okay, this much the total volume. This is Vt. Just remember, or you can calculate yourself. 424. Okay, now the value will be coming 1.29 gram per cubic centimeter. So this is void density. Now you know how to calculate void density. Then we will calculate specific volume. This is very easy. How? Because this is just inverse of void density. 1 by 1 point. For 1.29 I can write it 1.3. Okay. For convention or easy to calculate, the answer will come 0.76. Here the unit was cc, gram per cc. So here we can write cc per gram, the unit. Okay. Now we will calculate the porosity. We have void density value. We have particle density value. Okay. Now we can calculate the porosity. It's very simple. 1 minus void density by particle density. Just put the values. Now we get the value 50.51. Or for porosity, we will multiply with 100. Okay, so 0.51 into 100. So porosity percentage will be your 51%. Now you have calculate porosity. Then we can calculate void ratio. Which is, we have already written the formula by interrelationship, which is porosity by or upon 1 minus porosity. Okay, here 0.51 by 1 minus 0.51. Just solve this, we will get 1.04. Okay, now we got void ratio. If also we don't know the porosity value, we can calculate it from volume of pores by volume of soil solid. Okay, this volume of pore, we have total volume of soil total volume, sorry, this is the total volume Vt and Vt. Okay, Vt you know, Vt minus volume of soil solid, we can get the volume of pore space upon Vs. So we don't have now the value of Vs. Now we have to calculate that is Vs. Vs is we know the density is mass per volume. So what will be the volume? Mass per density. We can calculate this from mass of the solid by density of that particle. So mass of the solid was 550. Here we have seen ms. Okay, ms value we have seen, and particle density normally 2.65. So from here we can get the value 207.6. Okay, just 2 here, 207.6, and differentiate it from Vt divided by also this Vs. We will get the voidratio value of 1.04. Okay, now if you want to calculate mass wetness, okay, we have already seen that is mass of water by mass of soil solid. How we calculate mass of water? That is the phase weight. Initially what was the weight? Along with water it was phase weight. It is called as phase weight minus oven dry weight or ms divided with oven dry weight. What is the value of phase weight? That is 675 gram. Okay, just put those values. You will get the value of 22.7%. Okay, now I am running this. Now we can calculate volumetric moisture content from here. We have calculated gravimetric moisture content. From here we can calculate also volumetric moisture content. Very simple. Into ball density, gravimetric moisture content into ball density value. We can write the value is 29%, 29.5%. You exercise yourself. You will find this value. Because of less time, I have written down. Okay. For calculating the degree of saturation. We have seen the formula. What it was? The degree of saturation is calculated by volume of water by volume of pore space. Okay, we have now known the volume of water value because it can be calculated by, as I have already told, the density is equals to mass per volume. Okay, so what will be the volume? That will be your mass per density. So mass of the water was 125. We have calculated here 125, and density of water is normally 1. So volume of water we can write it here 125, and volume of pore space is total volume of soil minus volume of soil solid. We have these values, so put this, we will get the value 57.6%. We will get the value of degree of saturation 57.6%. You exercise yourself. You can have. Okay. Lastly, we can calculate from here the air filled porosity. We can calculate from here the air filled porosity also. You see this much value we can come across all those parameters. Okay. That's why I have prepared this problem only to get yourself more acquainted with all those parameters. This chapter is generally depends on your practice. The more you practice, the more the concepts will be get clear to you. Okay. The air filled porosity, you can write total pore space minus volumetric moisture content. Okay. In pore space, what content? Air and water. We are removing the water. We will get the air content. Simple. We have this pore space value and this volumetric moisture content value. just put this, you will get 21.49%. Okay. Now this way you solve more problems. Okay. If any doubt comes, just ask me through comment section. Okay. Or in description also I have written my number. You can contact through any WhatsApp or social media also. I just love teaching, so don't hesitate to ask whatever the doubt comes. Then another important question that was asked in most of an exam: calculate the weight of a, from this chapter. This type of questions are mainly asked. What is the weight of a porous-like layer? Porous-like soil or porous-like layer of soil? Okay, this porous-like layer we normally know when talking about porous lines. Okay, we normally know the depth is 15 centimeter. Okay, or we can write it 0.15 meter, and the area of porous lines is normally it is 10,000. It may be given that in 1 hectare is calculated. In 1 hectare is how many meter square? 10,000 meter square. Or we can write 10 to the power 4 meter square. Okay, and another thing from this we may know this bulk density. This value is normally 1.33 megagram per meter cube. Okay, so now calculate the weight of this porous-like layer. Okay, so what is weight? What is weight? Just for simply calculation of weight, we should multiply all this. Okay, very simple. But normally students what they do, just mug up. Okay, for calculating weight, we just multiply all this. That is 0.15 into 10 to the power 4 into 1.3. All these are in SI unit. Okay, I have converted all these in SI unit. So just multiply. You will get the value, but 1995 megagram. Okay, or we can say this as nearly equal to 2000 megagram. Okay, also we can write this 2000 megagram as 2 into 10 to the power 6 kg per hectare. Okay, this is normally asked in objectives. What is the weight of a porous-like layer? But if you know the calculation, it will be a longer period in your memory.